This is the demo for our project. As you can see, FPGA is connected to the USB and it's also connected to the VGA display. And we coded the FPGA to display different colors and different shapes on the monitor. And we connected keyboard to set up the different modes on the FPGA. What I mean by that is that it's the different calculation modes for the ALU. For example, let me reset this. For example, if I press Q, that's for mode 0. If I press W, that's mode 1. E is mode 2. R is 3. And so it goes on. This way you can actually set up the mode just with one key easily and switch between them. And the inputs are still used with the switches. For example, switch 4 to switch 7, that's for A input. Switch 8 to switch 11, that's for B input. And let me show you an example. If I press T, that's mode 4, and that's A plus B. And if I want to do A plus B examples, I can do like 1 plus 1. Oh yeah, I need to switch the numerical mode. Okay, now if I do 1 plus 1, it gives me a 2. If I can do 3 plus 1, it gives me a 4. Or like 3 plus 3, it gives me a 6. And if I do something like with bigger than 3 bits, it does the overflow, which happens when the addition is more than 3 bits. And another example can be with Y. What Y does is that it does A minus B. And here's an example for A minus B. I can turn on 8 and I can do 8 minus 4. Sorry, A minus 2. That's 6. Or I can do 2 minus 4 and it gives you a minus 2. Or 2 minus 12 and it will give me a minus 10.
Okay, so here's code review. We'll start with the overall system, and it's better to look at the whole schematic here. Essentially what happens is we use the keyboard as the input for all of the modes, and that gets fed through the keyboard handler, and it has its own clock signal, and that gets fed into the ASCII decoder. And the ASCII decoder converts the keyboard scan codes into ASCII codes, so it is easier to read by the normal decoder, which is the next step in the line. And the normal decoder takes in the ASCII inputs and assigns the proper modes to the ALU and to the 7-segment displays, which are the next in the line. And the ALU does its computations and sends its result to the 7-segment displays, while at the same time, the VGA connection is essentially a standalone module, which Murat will talk about now.
In the VGA display, we first set up the inputs, outputs, and then to set up the monitor, we used clock refresh signals and the codes, and then later in the last part we try to draw different shapes in different types and colors.
And that is pretty much the entire design. Some things we wanted to change, but we're unable to, were we wanted to make it so the keyboard was also able to toggle the input bits, but there's some issue with the way that the flipping each bit worked that we couldn't resolve. Some functions would work, like mode switching, and then the bit switch wouldn't work, and vice versa. They didn't want to cooperate, so we had to compromise and use the switches as in the original lab2 to control each bit of the input. But otherwise, it has the full functionality of everything from lab2. And the keyboard it makes it a lot easier to remember each different mode, as each key is assigned to its own function, so it's a lot easier to remember. Makes it a little more user friendly. But otherwise, that's the entire design. Thanks.